Now I'm officially recording. I forgot to record yesterday, or didn't.
You're screwed. I'm screwed?
Yeah.
Tell him I said hello, would you?
Yeah.
All right.
Did you record yesterday?
Yes, sixth period. They were in shock. All right. Problem number 7. So we have this cone. All right, so we know that this is 2, this is 6, and this is also 6, and this is 4, right? All right, I think, so find the total area. So let me just find the area of this real quick, of that circle. So that's pi r squared, so that's pi times 2 squared. So 4 pi is that little area. So we know we'll have to add that in. This will be added in at the end. Be sure to add in. Add to end. Okay. So I want to find, I'm going to find the surface area of just the cone on top. So that's just going to be pi RL. So that's pi times the radius times that. So that's going to give me 12 pi. So that's just that top cone. Then I'm going to find the entire cone. So the entire cone's lateral surface area is pi RL. So the entire cone is pi RL. So I have pi. The radius of the bottom is going to be 4. The entire slant height is going to be 12. So that's going to give me 48 pi. Okay? So if I subtract 48 pi from the small cone, I'm going to get 48 pi minus 12 pi. So the whole cone minus the small cone will give me the leftover cone. So that would be 36 pi is the lateral surface area of this. I have to add 4 pi to that because I have that. And then down here, the area of the bottom circle is pi r squared. So that's what, 16 pi? So then I'm going to add
56 pi.
16 pi. So then I wind up with 56 pi square units. That's how I would have approached that one. Okay. Was there a quicker, better way? I didn't see it right away, so I apologize. If there was one where you just had to plug like the number 11 in and all of a sudden it works. But I don't think so. All right, what else did we come across on this worksheet? Yo, Johnny.
8.
Number 8. All right, so you have the total area of both. Number 8. So you have a cone. And we know that the radius is 3, but then they tell us that the true height here is 4 and the true height of this is 6. Okay? So let's figure that out. That is 6. That's a 90. So that's L. So let's find, I have 3 squared plus 6 squared equals L squared. So that's 9 plus 36. So 45. Root 45 is equal to this. Is that okay? And yes, you could break that down 9 times 5. So that'll come out to 3 root 5 is that lateral height. And then let's figure out the lateral height over here. Okay, so again, that forms a 90. You have a 3. That's a 4. Oh, that's got to be 5, right? Because that's the old 3, 4, 5. So I'm going to do pi RL plus pi RL. So let's see, pi times R is 3 times L is 5 plus, bless you, pi times R is 3 root 5 and times 3. So that's going to give me 15 pi as that. And then that's going to give me 9 root 5 pi square units. And again, you didn't have to work. You only found the lateral areas of both cones, not the entire area. Okay. What else? Aren't you guys done with snow? I am. Yeah. For this year. Four?
Hey, what is this?
It's math class, but we're
No, Colorado's
bipolar weather. Number 4. I'm sorry.
It's your fault, Mr. Calculate the weather better.
Dave Aguilar is my neighbor.
Yeah.
No, Dave Aguilar. He's the news guy on Channel 4.
You're wrong.
50-50. It's always 50-50. All right. They want us to find the lateral surface area and the total surface area. So I have to realize that there's a right triangle in here.
41.
That's going to be L. So that comes out to 41 if you use the Pythagorean theorem. Is that what you're telling me?
Yep.
Dude, I'll take that. So pi RL finds me the lateral surface area. So pi times 9 times L is 41. So I get 369 pi square units. That's the lateral. That's just the cone itself. And then I would have to add pi r squared to that. So pi r squared is 81. So if I add those together, I get pi. What does that come out to? 74. What? 450 pi square units. Cool. That'll work. What else do we come across there? 6. All right. Number 6. Find the lateral area and the total area. Okay. So they have this. There's a 90 angle there. This is 10. This is 30 degrees. That's so you have this right triangle inside. Let me pull that right triangle out. If this is 30 here, this is the hypotenuse, which is lateral. What's the relationship on a 30, 60, 90 between the hypotenuse and the side opposite of 30? Divide by 2. So this will be 5. So lateral area is pi RL. So pi times the radius times L. So 50 pi square units is the area of the cone itself. And then now that I found the radius, I'm going to add pi r squared. So pi times 25. So that's 25 pi. So 75 pi square units will be the entire surface area. So lateral surface area, entire surface area. What else? Whoa. You doing all right? All right. If you would, make sure you're y2 minus y1 over x2 minus x1.
Wait.
x1, y1, x2, y2. y2 minus y1 over x2 minus x1. All right. Let's see here. All right. Of course, my slides didn't come out again. All right. So we are going to talk about volumes of prisms and cylinders. Extend previous understanding of volume, including finding more complex volumes. So the number of cubic units contained in the volume of the interior solid. What is true about prisms? What's true about a prism? Okay. Length and width and height, I like that. What else might be true about a prism? Two bases, cool. So two bases is what I'm looking for. You have two bases. And the bases are parallel to each other. Okay? Bases are parallel to each other. So that means you're dealing with a prism. The bases don't have to be on the top and the bottom. You can have it lined sideways. You can have it diagonal, whatever. Cool? All right. The volume of any prism. Yeah, the volume of any prism is the length times the width times the height. You have three different dimensions. The dimension is dictated by something that's perpendicular to something else. So length times width times height. Okay? And again, each of those dimensions is offset by 90 degrees. You're in a three-dimensional thing. Once you talk about the volume of something, it is now in cubic units, or cubic feet, or cubic inches, or cubic yards, or anything like that. Okay? So, what polygons can you find the area of? Okay? Well, you have a number of triangles that you are able to find the area of. I mean, you have areas equal to 1/2 base times height. If that doesn't work, you have one area equals 1/2 AP sine C.
Absolutely.
Right? Where A and B are the two sides, and C is the angle in between them. You also have your S equals the partial perimeter, and then that's equal to area is equal to root S minus A, S minus B, S minus C. So there's that. You know the old rectangles and squares. Yeah, it's just base times height or length times width. That would find you areas as well. You also know that using n minus 2 times 180 divided by n, and then figure out all the angles. And this is if you have a regular polygon. Okay, regular polygon. I have the hiccups, excuse me. N minus 2 times 180 divided by n. Find the angles, and then you work it into figure out 1/2 ANS, or some teachers, because that says anus, they prefer to say AP, for P as being the perimeter, and perimeter is N times S. So those are some things. Okay? You know trapezoids, right? That would be, in order to find the area, it would be 1/2 base 1 plus base 2 times the height, where the bases and the height are perpendicular to each other. The bases are parallel to each other. Okay? So, let's take a look at that one. Let's find the volume of this. That's 14. That's 6. That's 5. And they give this height here of 3. So how would I find the volume of this? If I found the area of the trapezoid on top, so area of the trapezoid is 1/2 base 1 plus base 2 times height. So 1/2 base 1 plus base 2 times the height. So that's what, 20, half of 20 is 10, 10 times 3 is 30. So 30 square units is the area of the base. And now if I wanted to define the volume, it's the area of the base times the height of the object. So what's the height of our object?
3.
The height of our trapezoid's 3.
5.
5. So my volume is equal to 30. That's my area of my base times 5. So I wind up with 150 cubic units. And that's how I find the volume. Okay.
No, that's terrible. No,
What did I do?
not you.
Okay. Sammy. Next one. What kind of prism do we have on the next one? Hexagonal, right? The old six-sider.
Zach's back.
Zach's back. He brought pizza. We missed you, Zach.
We did?
I did. I cried a little bit. Starting to weep these days. So that's 12, and that's 6. So we have to realize we have n minus 2 times 180 divided by n. So that's 720 divided by 6, which is 120. So each angle here is 120. You have your apothem. You have your radius. That's a 90-degree angle. This distance right here is going to be half of base, so that's going to be 6. So I'm going to pull that triangle out. 6, the apothem, the radius. What am I looking for to find the area? The what? The apothem. So that's a 60 there, that's a 30 there.
Good job.
So I have opposite of the 30 is 6. The apothem is opposite of the 60, so 6 root 3, good. Okay, do I need to find the radius?
No.
No, it's not necessary. It's 12 for those of you overachievers who want to figure that out. So area is equal to 1/2 A and S. I have 1/2 the apothem, which is 6 root 3. Number of sides, 6. Length of each side, 12. Still with me? Okay. So if I multiply that together, I believe it comes out to 216 root 3 square units. So that's the area of the base. Do we agree with that?
Yes, sir.
Okay. So now, in order to find the volume of this, it's area of the base times the height. The area of the base is what? 216 root 3. Good. What is my height? 6. What is 6 times 216? 1296, maybe? Cubic units? Did I do it right? I don't know. Shirley. Call me Shirley these days. Shirley. So 216 times 6 is 1296. Sweet. So our volume is 1296 root 3 cubic units. So if we were to fill this whole object full of liquid or air or gas, that's the volume of it. On the backside. Still doing all right? On the backside, we have a regular pentagonal prism with base edge 8 and height of 9. Okay? We can do it. Oh, I'm so untalented. Sorry, I don't know what you guys would do if I had a different teacher. I like math. Let's see. So I have a regular
Pentagonal prism.
with a base edge of 8 and a height of 9. Okay. So pull out the old pentagon. N minus 2 times 180. Oh my goodness.
Wait, what the heck?
Don't pay attention to that. Can't get it off the board quick enough. Ah! Like, what's wrong with your teacher? I don't know. Just let him be. All right, that'll be better for us. Sorry,
I like the other one better.
me too. So that was 8. I have an apothem. I have that. That's a 90-degree angle. So n minus 2 times 180 divided by 5 means each of these is 108, which means this is 54. So let's pull that triangle out and take a look at that. That's 54. That's my apothem. How long is this distance right here got to be? 4. Good. Okay. So it looks like I have opposite and adjacent, so that's tangent. So I get tangent 54 equals a over 4. So 4 tangent 54 equals a. You have a, how much? 5.5? Thank you. So I know my apothem, so now I can use this, going 1/2 a and s. So the apothem is 5.5.
Yeah.
Is that right?
5.5.
Number of sides, 5. Length of each side, 8. Help me out, please. 110? I'll put 110.0 square units. That's the area of the base. So in order to find the volume, it's going to be the area of the base times the height. The area of the base we found is 110.0 because it's not exact. No, because 4 tangent 54 didn't come out exact.
Sorry.
Times 9, so that's going to be 990.0 cubic units. You guys and girls, please realize that if it's not an exact value and it still came pretty close to 0, make sure you put the .0 there. That tells the grader that you have a little extra.
So you want us to do that for the quiz?
Please.
Yeah, Dawn.
Sawyer? I don't like your attitude.
Yeah.
It's
Oh.
hurting all our feelings.
Yeah, it hurts. Makes us want to cry. All right, find the volume of the triangle. We had already done that yesterday. If you were to find the area of this in 5, what's the equation? Square root 3 over 4 times side squared, right? So that's going to be 25 root 3 times 4. That's the area of the base times 8. Stop packing up. You're making me nervous. So I wind up with a volume of 50 root 3 cubic units. Find the volume of the two things. Well, your top has a volume equals 1 times 2 times 4. The bottom has a volume of 1 times 2 times 5. That's length, width, and height. So that's 8. That's 10. Add the top box to the bottom box. You get 18 cubic units. That's the volume. And then what about a cylinder? In order to find the volume of a cylinder, it's pi r squared height. So if you had a radius of 3, a height of 10, volume equals pi times r squared. That's 9 times 10. So 90 pi cubic units. And then not enough time to finish the last one. I'm sorry. So tonight, make sure 11.5 is done. We'll go over that tomorrow. And then 10 minutes more of something else. And then that's about it.
Sam, what number are you?
Have a great day.